So today, what we're going to be talking about a little bit about is an overview on DNP3 protocol. We have a special guest today with Gil Blackburn from BCI Technologies. And with Xperts on tap, what we like to do is kind of dive in a little deeper into some of these different unique presentations that only last 30 minutes. So with that, I'm going to pass over control over to Gil. Gil, are you there? Are you still muted? Gil, are you muted? You're muted. You were muted.
Okay.
And here's your, you're just going to show your screen?
Okay, hang on 1 second. I believe it's screen 2. Everybody see that?
Yep.
Okay. All right. I'll consider myself the secret sauce then.
You're the secret sauce today.
How you doing, everybody? Again, my name is Gil Blackburn, BCI Technologies. We're out of Kissimmee, Florida. Just going to kind of briefly cover this. There we go. We've been in business 30 years. We were the SciTech distributor for 22 years, and for about 14 years, we've been the Schneider Electric telemetry and remote SCADA solutions. And we have about 32 years experience with both SCADA and automation, and 23 years I have with DNP3. My main background is in the power industry and water industry, but I gained my DNP3 expertise in the electric power utilities. So what I'm going to cover today is a very short history of DNP3, some key terms, why you might want to choose DNP3, some of the polling techniques. There's some right ways and wrong ways of doing it that people have tried in the past, some advantages and disadvantages of DNP3, and any questions you might want to ask. And if time allows, I'm connected up to a little SCADA pack RTU talking DNP3 into telemetry server, so I can show you how it backfills and things of that nature. All right, so the 3 things that I want you to get out of this presentation, and I think you should get out of it, is basically the benefits of using a non-proprietary protocol like DNP3. That's a very important concept. When I get to the history, we'll cover a little bit of that. The benefits of the protocol, the benefits of the protocol being separate from your physical communications. And what that means is if you change from licensed serial to cellular IP, your protocol does not change like in the Modbus world. And then, and most importantly, gain an understanding of what timestamp, report by exception, and unsolicited response polling is, and how that works, and how that can benefit you. Short history, GE Harris, which was originally Westronics, developed DNP3 back in the early 90s. They turned over the ownership to a users group, so it basically became non-proprietary. And it's consistent mainly of utilities and vendors that have enhanced that protocol. And again, it's an open, published protocol, and it's completely documented, very tightly regulated. So you can't just add your own data type into the system. It goes through a technical committee, and that's what that last piece says. Okay. Some key terms, just so when I'm talking later, you'll understand it. Master is your SCADA system, in this case, telemetry server. Outstation is your remote RTU or PLC out in the field. In this case, I have a SCADA pack RTU. Report by exception, these are event records that get generated based on change down in the RTU. So as opposed to Modbus, you're polling it, and whatever the status is when you poll it, that's what you get in your system. Every time something changes down in the RTU, it gets timestamped and put into event buffers. So binaries whenever they change state, analogs based on deadbanding. And so it's very similar to how you might do something with a historian. Static data is really what the current value of the point is right now. And that's considered what's called a level 1 functionality. Event class data, which is classes 1, 2, and 3, those are timestamped records that are generated down in the RTU. And they're held in the RTU when they're either polled by the master to say, hey, give me all your events, or some alarm condition or condition that you want called an unsolicited trigger happens, and then the RTU will actually push that data up to the top end. And you can mix and match all these polling routines. Unsolicited response is when you have event data pushed up to the master without being polled from the RTU, and that's what's considered a level 3 functionality. Some vendors talk about the level 1, 2, and 3 functionality, that they're level 3 compliant or whatever, and we'll cover a little bit of that later. Time synchronization, if you're going to have time synced data that comes back up into your SCADA system, you need to have the clock set out in the field. Well, that's all handled by the protocol. Telemetry server on startup will automatically set the clocks, and normally we set it to once a day to sync all the clocks. So when all your data comes in, you know, everybody's in the same time sync. Integrity polls typically done. I like to do them once a day, but they can be done whenever you like. But it's a poll that says, give me what's happened in the past, all your events, and then tell me what every point in the system is right now. And an integrity poll can be just a class 0 poll, which is just tell me everything the value is right now. And then again, I call this, the integrity poll is your warm and fuzzy blanket. How comfortable are you with a change-driven system? Some people don't like change-driven systems. They're going to do 3-hour integrity polls. Some people are completely comfortable with it, and they're going to do it once a day. It just depends on what your comfort level is, completely tunable. Event polling, this is where you set up the master, which is telemetry server in this case, to poll your different class events. And you can poll them all at the same time or at different rates if you want. If you have a lot of data you're trying to collect, you may want to pick up your, your real critical status data, a little quicker than maybe your daily run times, which you could pick up once a day. So anyway, that's what event polling is. And again, what that allows is much lower bandwidth requirements, particularly everybody moving to cellular. You're concerned with how much data you're actually going to move over the network. So this allows you to heavily control that. DNP3 device profile, every master station, which is the telemetry server in this case, or RTU, SCADA pack or PLC, that says they're DNP3 compliant, needs to fill out a device profile, and you should always ask for that. That tells you don't have to support everything, but you have to basically say what you do support and what you don't support. And again, they're required to have that. Okay. Object types, this is a little bit techy, but not too. If you're familiar with Modbus, you have the 40,000 holding registers. 40,001 is the first one. An example in DNP3, they use groups and variation number of the groups. And I'll explain that in a second. The group type for analog inputs is 30, okay? The variation type of that, it might be a 32-bit, might be a 16-bit, might be a float, okay? When you're talking about these together, that definition comes up in the protocol and it automatically gets handled by telemetry server. It doesn't matter whether it's a float or whether it's a 32-bit long or anything, it just gets processed. And that variation type is spelled out in the message that comes back with every single value. There again, in this case, a 32-bit integer analog is a object group 30, variation 1. The important thing to take away here is DNP3 is a very, very mature, well-developed protocol. There's 160 different object types and variation types. I'm certainly not going to go through all that. That's the important part, is that it has counter objects and everything you could think of, even file transfers, is built into the protocol. It also has DNP3 Secure built into the protocol, which is authentication. And so down the road in the water business anyway, that wand's going to be waved, and the government's going to say, thou shalt be secure. DNP3 already has that worked out into the protocol. Okay, why would you want to choose DNP3? Number one, extremely scalable. It can do very, very large systems. Florida Power and Light monitors 1,400 substations. Usually they have fiber running into them, but basically they have, millions of points that they're monitoring. Well, it supports up to, on a particular channel, 65, 535 remote outstations. So we can get really large. Data integrity, you have timestamp data down to the millisecond. Data quality flags always come in with that data, so you'll know whether that value is over range, under range, or out of service in the PLC. There's several quality flags that'll get passed back through the system. No data loss. I'll say virtually no data loss. If communications go down, the timestamped events, they're buffered up out in the outstations, and then when you do poll them, it gets backfilled and backfills into the historian when your comms are restored. In the Modbus world, if your comms go down, you don't have data. It's just lost. You have a hole in your history. Very flexible from the standpoint of polling schemes. You know, and the important thing is a system that has 10 remotes is not going to be set up the same way as one that has 800 out there. So it's very tunable. You can change it around. You can change it after you set it up. It's not a big deal. But that's all handled at the master station. Okay, there again, security is already designed in. We covered that. Allows you to prioritize your data into 3 different classes. Really 4 with class 0. But basically, I like to put class 1. I like to put all my alarms in class 1. And then maybe my daily counters in number 3, and all my normal process data in class 2. It just allows you to control when things are going to happen and where your data is. Critical alarm data, there again, this is unsolicited response, gets pushed up. So if you're polling a lift station every 15 minutes, which we have many, many customers doing that, and the lift station guys, if they're on Modbus serial right now, polling on a radio system, they're saying, oh, that's a long time. But if you have a high-level condition, okay, that occurs 30 seconds after you polled it, in Modbus world, you're going to wait till your next polling cycle to get that information. With unsolicited response, it gets sent in right away. And I can demonstrate that with the RTU that I've got here. Again, time synchronization. We normally do it every 24 hours. DNP3 polling, static data is class 0, and then basically it's one command that goes down, and you get one big long list with a one timestamp, and it updates the entire database. So you know what everything is right now. Event data is where you set it up in the RTU to say if it changes state or it breaks through a deadband, make me a record down at the RTU. So essentially what happens, this is the report by exception piece. You can report several events on the same point. So if the level went up and down and up and down, and the pump turned on and off 14 times, and when you poll it again, you're going to get all that data time-stamped and put in the historian at the right time. There again, each point gets assigned to an event class, and each class has no priority unless you prioritize it. That's just a completely user-defined. Your unsolicited response, there again, it's kind of a paradigm shift for SCADA polling if you're used to Modbus. This is where the outstation sends in that data. It's very scalable about, you can determine exactly what comes in. In the water market, we typically do a lift station for remote assets or a pump station or something like that. Whenever we have an unsolicited response, we typically send in every event that it has. So, and data that hasn't changed doesn't get sent because it doesn't need to be sent because you already know the status. My little saying is by slowing down the master polling, particularly if you're on a serial licensed radio system, okay, you need to slow things down so you can get a faster response times when you do have alarms. And at any point in time, you can always poll a station. If you're looking at it and you want to get all the details right now, you just say poll that station, and it just interrupts that polling cycle and reads it right away. There again, your background cyclical polling gets your changes on that. So there again, this is what I could consider a good polling strategy for your medium to very large systems, what I call a hybrid. You're doing unsolicited and you're doing polling, and it's a mix of it. Okay, ways not to do it, okay? The Modbus guys want to do integrity polls as fast as they possibly can. Please don't do this. You'll be completely dissatisfied with the performance. The overhead with DNP3 is higher than Modbus, but if you're getting all the data all the time, every time you poll it, you've got a worse system than you would in a Modbus scenario. And there again, DNP3's gotten a little bit of a bad rap because of that, because they just haven't properly tuned it. The other way is a doable way, but it's all unsolicited response. If you're on fiber and you don't care about bandwidth, anytime something happens in the field, you want to know about it, you can set it up to where it just sends in that data. And if you're on fiber, that's not a bad solution. But the issue is when you're over a limited bandwidth, or if you're over cellular, you just don't want to keep having all those transmissions coming in, particularly if you had a power bump across your whole system, you're going to have a data storm coming in. So we want to control that. So the correct way, in my opinion, is there again, do a combination of integrity poles and event poles with unsolicited setup on all your alarm conditions. Then again, the master on startup gets a full picture once a day of what's going on. There again, that's your warm and fuzzy blanket to make sure that you haven't missed anything. Slower event pollings, again, 15 minutes is a good one. It just depends on your scenario, but again, I like to call it slow it down to speed it up. Particularly if you're on licensed serial radios, you're leaving quiet time in the protocol for unsolicited to come in. And then what you do is when you have, there again, unsolicited, you're notified right away what happens. And I like to set up the outstation to send in everything that it has whenever it has an unsolicited trigger. You just get a complete picture. So if you have a pump faulted and you don't want to see the pump running, for instance, because it's not running if it's faulted. Anyway, okay. A couple little setup screens just to show you how complete the telemetry server is. This is set up for your integrity pole. You can set it up. This is set up for one day. And it happens to be, you can offset it. So you can control how you're doing this. If you have 100 stations out there, you can stagger that integrity pole if you want. This happens to be on the day plus 10 minutes. So at 12:10 midnight, it's going to do an integrity pole. Down here is where we're getting the different polling scenarios for your class polls. If you're doing lift stations, I set all these the same. Set it at 15 minutes and you'll be done with it. Again, you can control that offset. This is setting up your unsolicited messages. At the top end, you can basically say, look, I'm going to enable unsolicited messages and control that at the top end. And what that is again, if you've got 100, 200, 300 stations out there, you don't want to get as soon as you go online, you don't want to get a data storm coming at you. So this is a way that the master can control that system. So it first says, hey, be quiet, let me get all your data, then I'll enable your unsolicited. And then you start moving forward. It allows for quicker startups. Here's where you're setting the clock. This is just the controls inside of telemetry server. And this is what we're looking at right now is the telemetry server. Now I'm jumping down to an RTU just to give you an idea of what's involved in that. See, here's a binary point, a digital input. It's group 1, variation 1, binary input. It's been assigned to class 1. And this particular one is set up for unsolicited. So anytime this point changes, it'll trigger the RTU to send data up to the top. Okay, it's very easy to configure that. Here's an example of an analog point. There again, group 30, variation 1, 32-bit analog in, class 1. Here, it's 0 to 10,000 is what the scaling is. Every 100 units, it's going to generate a event log in the RTU. So when it's polled or we get an alarm, it'll send that in. Here's some other setups where basically you can set up where there's limits inside the RTU that I want, if it crosses 2,000, I want an event generated, no matter where it is in the deadband. If it crosses either direction on 1,000, I want it to be get an event generated, and I want that to be an unsolicited trigger. So that all can be controlled down in the bottom end of the RTU. Here's some polling examples. That just is a little bit of animation here. So in this case, I have I have a breaker here, but that could just as easily be a pump or a fault or whatever. So what happens is we have what are your values right now? We're doing that integrity poll. It says, okay, your breaker's closed, your current's 100, your voltage is 12,702, plus another 150 values that are along in this list. Okay. So the next poll that comes in and says, hey, just tell me what's changed. Well, the only thing that's changed is the current went to 98. Okay. Poll it again. Okay, your voltage changed just a little bit on those two legs. Okay. So it only passes the changes, and that top list is much larger than the bottom list. So you're controlling the amount of bandwidth, particularly important when you're dealing with cellular. The next is now doing the report by exception, just a little bit different scenario. I'm going to come through. There's my current. So what happens is we have the recloser application. So it opened and closed, opened and closed. Okay, and now I polled it. What's going to say is, hey, what's changed? It's going to tell me, hey, your breaker opened and closed and opened and closed at these timestamps. Okay, all that data, your alarms and everything else will be timestamped appropriately, and it'll go right into the history, and you will see all those open and closed without you didn't poll it in the middle when all that happened. Now the next scenario is unsolicited, and this is, to me, is really the secret sauce in how to set up a system, particularly in the water business, is where you poll it, same kind of scenario, where we go through and we get our statuses. We go through that same alarm sequence, but instead of waiting to be polled, the RTU forces that back up. And what actually happens in the real world telemetry server will actually acknowledge those, and then it'll flush its buffer. So it clears that buffer out. So that's, like I said, your different polling examples. Let's see. Some advantages. It's been around a long time. It's very, very well proven. Every master and slave device has a document that should tell you what it does and doesn't do, as opposed to you trying to figure it out. Again, scales up very well. Very flexible polling schemes depending on your. One size does not fit all, but it allows you to tune it. Supports report by exception, your time-stamped events. There again, you don't lose your data if there's a comm failure. Supports that unsolicited response. So you know about, again, I ask lift station supervisors how long you want to wait for a high-level alarm. And usually the answer is not very long. So it's within seconds. One of our customers down here in Florida, literally they get a text within seconds of it happening. There again, slave communicates directly to the master. With, for example, fault condition would trigger that. Okay, very complete support for all the data types that are out there, and again, they have counters, they have, all the analog inputs and analog output, control points, pulse points, all that is in there. It does support peer-to-peer communications if you need that in your application. I don't use that very often, but it does come in handy. Supports both serial and Ethernet communications, and again, I touched on that, but the important part of that is the protocol does not change. It is removed from that physical layer of the OSI 7 layer when you're in communications. So you don't have to. There's no Modbus RTU serial and Modbus TCP/IP. It's just DNP3. Again, there's the top. I just ran through that. So there again, security is also built into it, and I'm not really covering security here, but it's basically authentication, and it prevents your man-in-the-middle scenario of somebody trying to turn on your pumps. Disadvantage, it is a little more complicated than DNP3. There's a little bit of a learning curve to it, but it's well worth it. You have to think about your system more because you're pushing some intelligence down at the RTU level. And so you have more choices to make down there. Again, requires tuning and the right bandwidth. The last thing you want is too tight of bandwidth on your deadbands because you get too much data coming back in. Again, requires additional RTU. You need to assign classes and set your analog deadbands. And if there's any consultants here and you're doing a DNP3 system, take the extra step, or end users, take that extra step to assign the classes. If you got an integrator doing your job for you, tell him where you want those to be assigned. Tell him what you want the deadband to be, because otherwise they'll be all over the map and you'll spend a lot of time during your startup. Is it right for you? Now, my question is your data important to you? If your comms go down, is it acceptable to lose any data? Is it acceptable to wait to the next polling cycle to be notified of a critical alarm? You know, my opinion is no, but again, or do you want to wait seconds to get it? The things I hoped you got out of this, okay, are, again, the benefits. It's a real proven track record. I don't know the exact number, but somewhere north of 95% of the electric utilities use DNP3 as their primary protocol. It's not proprietary to any vendor, so you can change RTUs, you can change software, and it's still compatible in your system. Your security's already been worked out. Again, separation of this, and the separation of the physical communication, the protocol doesn't change, is, you know, if you have serial licensed radio today and you're thinking about going to cellular, not a big deal. It really isn't. And we have customers going through that exact scenario. Again, I hope you gained a little bit of understanding of basic what timestamp, report by exception, and unsolicited response, how it works in the system, and all that data backfills into the database. Let's see. This is a little demo I've got set up. I think we have enough time for that. We have system platform set up here. I have the telemetry server running. It's going DNP3 back and forth, and we're passing that data back up into what I don't have brought around as the historian over here. And then here's a little SCADA pack RTU where I got a couple switches and an analog simulator tied into it. So let me see if I can get that. I'm going to pop out of my real quick here. Bear with me 1 second. Okay. So what I've got going, let me see if I can get it. I've got this, the telemetry server polling every 5 minutes. Okay, so every 5 minutes on basically synced up to the hour. It just turned back on and we got a poll going, and I have a couple of switches. So what I'm going to do is I don't know whether you can hear this, but I've turned on, off, on, off. This is a pump that I'm turning on and off right now. Okay, and what I'm going to do is I'm going to force a trigger in this particular case, and in just a few seconds you'll see. I hope you can see that. That was that pump going on and off, and this is that fault condition, or high float in this case, what I have it labeled, turned on. And the high float is set up to be an unsolicited. So I'm going to take while we're not polling right now, I'm going to run the level all the way up, which is the top line, by the way. This is the pump, and here's my fault condition. Okay, and I'm going to run it all the way back down. Now, if I just waited 5 minutes, this will actually, it just backfilled back in. I happen to catch it right. So basically, I'm going to run that up, run that down. Okay, I'm going to turn the pump on a couple of times. And then now I'm going to cause an alarm again. Actually, I think I have something unsolicited set up. So I'm getting my updates. Every single one of my pump transitions, I'll turn it into 1 minute. All these right here, it caught all of it. So I'm off, on, off, on. And we could wait for it to poll it. I'm going to run my level down. But I'm going to turn on my fault condition. In just a few seconds, it's going to backfill that. So my level went down, and there again, I caught my on-off right here. And there's when I actually transitioned it back on. So with that, I don't know if there's any questions. I don't know whether you can unmute people or if there's any questions that have popped in. Jason?
Yeah, actually, we have a question right now.
Okay.
Just wait a second here. I was looking at it.
I can give a shot at that answer if you want, Jason, but it's pretty loud in my background, so forgive me.
Okay.
Yep.
Well, the first question is, do you have a feel for how the hardware costs go up or down using DNP3?
Well, with a SCADA pack, it doesn't have any impact at all. I will tell you, there are many vendors. Allen Bradley, and I'm thinking lift stations right now. Allen Bradley, has the MicroLogix 1400 supports DNP3 natively, and we've worked with that. There's no additional cost for DNP3, it's just in there. If you're with the compact Logix or control Logix, you have to put in a module for that to make that happen. And so there is a hardware cost to that. And again, in the case of SCADA packs, it's just natively in the unit.
Okay. Next question. I guess Rich, you can answer this one. Why has Wonderware not had DNP3 before if this is not new?
Yeah, it's kind of a complicated yet simple answer, I guess. Gil, you weigh in at the end, but basically, if you take into account all the products we've had through the transformation from Advensys to Schneider to Viva, many of the products had DNP3. If you're talking about Wonderware specifically, it took a little bit longer because we were waiting to see which implementation we wanted to use, and we end up using the ClearSCADA software stack for DNP3. And that's what Gil's demonstrating here, and I think he endorsed the fact that it's probably the best one of the multiple ones we had.
I would tell you this. I was a SciTech distributor for 22 years, and we implemented several DNP3 applications, and it was a terrible driver. My opinion is it's still terrible. But so 15 years ago, I got involved with ClearSCADA, which is out of the control microsystems line. And it is awesome. And what they did, because Schneider buys everybody, what they did is, like I said, is they turned around and they took the back end of ClearSCADA, which is now called GeoSCADA, and used that. And which I was thrilled to death, because I have all my automation tools and everything else. I can build this database up, and I'm not really getting in telemetry server per se, but it's all object oriented, just like System Platform is. So you make templates down at the bottom end that match templates instances at the top, and you can duplicate those. So it's extremely powerful. And to answer the timeline of it, why is it taking so long? It's a really, under the hood, it's a really complex protocol. And many vendors have done very dismal jobs implementing it.
Thank you. Thanks for helping there, Gil.
Yeah. No, next question. Could the DNP3 master read the digital outputs or just the digital inputs? For example, if the output in the PLC changes, does the master DNP3 read the output status?
Now, it depends on the RTU. I will say this. The binary outputs, if the RTU supports doing timestamped events on the digital outputs, the answer is absolutely yes. If it doesn't, you'll need to map them back into digital inputs. But yes, we can absolutely read the status of those points. That's where it kind of gets a hybrid answer.
Next question is there an existing document that I can use as a spec for DNP3 to integrators?
I'd have to go offline. I have some stuff that may or may be applicable. It just depends on. I have some documentation that I could pass out. That it kind of depends on your job and what exactly you're trying to accomplish. But yes, I can do that. And Jason, or Rich, I'll toss that in to get us connected up, and I can pass
sounds
it.
Good.
Okay, sounds good.
And by the way, I highly encourage you to get involved in how that RTU is set up, because a lot of the integrators are new to DNP3, and they do the best they can, but you end up with a marginal performance when you shouldn't have to.
All right, I think that is all the questions for today. Thanks again, Gil, for bringing her along on this journey. It's been great, and we have recorded this whole session, so we'll be able to send this out for everybody, those that couldn't attend and those that have attended, so you'll be able to get this. So appreciate it. Thanks, everybody. Have a great one.
Thank you.
Thanks, Jason. Thanks, Gil.